Now we can start. Good afternoon. I am Erdem Öztürk, founder and CEO of Productive Machines. The title of my presentation is about how manufacturers can increase the productivity without making capital investments like machine tools. Productive Machines is a customer-driven company. We have been talking a lot to the manufacturers since we started. We are a 4-year-old business, and consistently they have defined their requirements to us. So first thing here is ease of use. Sorry, I think I missed one slide. Sorry. So they define their requirements to us. The first thing is the reduced cost. Every manufacturer is interested in reducing their cost. When they reduce the cost, they become more competitive, and they are likely to get more orders. But then another problem starts. When there are more orders, then they have to increase their production capacity. So that's also another requirement. Usually they invest in machine tools, which is really expensive, £300,000, £500,000. It can be even more, depending on the size and the complexity of the machine tool. But I am going to show today that there's another way, in addition to instead of buying machine tools to increase the production capacity. And also in the sector, we all know that there is a waste problem in the sector, and to address that, companies do continuous improvement. Every year they can reduce the cost or waste maybe 3-4% every year with the continuous improvement initiatives. But we have demonstrated that we can reduce the waste around 20-25% in a week rather than 5 years' time with the continuous improvement processes. And how we do that? We have developed the SenseNC software. SenseNC is sensing the NC files before it goes to the machine. So it gives extra sensing capabilities to the machinists or CAM programmers. And when we developed that, we really pay attention to 3 things. First one was about ease of use. So every manufacturer that we talked to asked for ease of use. And they said similar things, like Andy mentioned, like they get different results from different CAM programmers, and there's a skills gap problem. So they said, can this solution be used by any CAM programmer? So that was a requirement, and we achieved that. So this solution can be used by any CAM programmer, even if they are only like 1 week in the job. And also, second requirement was they wanted an integration to the existing workflow. So they didn't want to create extra workflows. And we also achieved that with the integration into Siemens NX and other CAM packages. And also they want results, real-world impactful case studies. So since we started, we have done more than 20 different case studies, which gave really meaningful impact to the manufacturers. And I will share 2 of them today. And one of them is about reshoring. So reshoring is quite popular these days because of what's going on in the world. And we have a very successful reshoring case study where we had a UK-based manufacturer to compete with the overseas suppliers. And then when we have been working on this, when we have developed the product, last month there was a white paper published by Sandvik Manufacturing Solutions. So the title of the white paper was Trends in Manufacturing Software Usage. Our colleagues there talked to 354 respondents from the manufacturing sector, and 40% of them were from Europe. So 60% was from North America, and 40% of these respondents were from US. And basically, the question was, what do you want from the integrated software? What are the top 3 requirements from the integrated software? And the top 3 requirements were superior ease of use, demonstration of clear business case, and the third one was superior integrations. So when I saw this white paper, it was quite refreshing for me, because we basically had paid attention to all of these things when we developed the technology SenseNC. Just a little bit information about Productive Machines. So Productive Machines is a deep tech company. We combine the state-of-the-art machining dynamics technology. Machining dynamics technology is a technology that solves vibration problems or problems related to the physics of the process in general. And we combine this capability with the latest software engineering skills, and we created a production-ready solution now for the machining industry. We are 17 people, and 7 of these 17 people have PhDs in the subject matter. So we have 7 doctors of machines in the company. And we are a spin-out from AMRC. AMRC is the Advanced Manufacturing Research Center. So this technology has been developed in the AMRC in last more than 10 years now. And when we started, Boeing was our first investor. So they knew us, of course, before, and they were our first supporter when we started the business. The main problem we are addressing is the waste problem. So I'm sure you are very familiar with the workflow that goes from the computer-aided design to the final metal component. So the problem with this workflow is there's a disconnect between the CAM programmer and what's happening in the actual machine. So CAM software are doing a lot, but they are mostly limited to the geometry of the process. They cannot help the CAM programmers with the physics of the process. So the manufacturing engineers or the operators see the problems themselves when they press the cycle start button. There may be an excessive noise coming from the machine. There may be a tool breakage issues, or nothing might have happened in the machine. They go to the CMM, check it, and then they see some problems, and then they come back to the CAM. So all the important decisions, most of the important decisions are given in the CAM, and then there's an iterative cycle that starts. So typically 3 to 5 iterations is probable and happens a lot. And these iterations are causing extra waste in the sector. And also, after these iterations, maybe 3 or 5, somebody says, good enough, lads, don't touch it. So, and then they start producing these parts for months or years. And we know that the most of the machines that we have in the sector are not using the maximum potential of the machine unless the companies have done a lot of iterations on their machines, which is not feasible most of the time. So we want to address the waste of resources. We want to address the underutilization of the machine tool performance with our solution. And how we do that? We basically have a plugin inside Siemens NX CAM and other CAM software. We have to have a toolpath generated. So there needs to be a toolpath available for us to work on, but you don't have to enter the feeds or speeds. You can enter it so that we can show you what was it before and what is after. So to make a benchmark before and after, we look to what is the original feeds and speeds. But for our optimization to run, you don't have to enter any feed rates or spindle speeds, unlike the other solutions in the market which does process optimization. What we do is we basically autonomously optimize the spindle speed and feed rate to solve the problems related to the physics of the process. So I said we have done a lot of case studies. Typically, average saving we have given to a client is about 20% cycle time reduction. Of course, there is other savings in the preparation, manufacturing, and the quality assurance, but measuring the impact on all these individual items is really challenging for a software company like us. But we can easily measure the machine hour savings. And based on that, the savings that we have seen so far are in the range between 35,000 pounds up to 120,000, sorry, not pounds, euros. Euros. I converted them to euros for this session. SenseNC platform has 2 modules in it. So Feeds is the first product that I will talk about. It optimizes the feed rates in the toolpath. So it considers the physical loading on the tools. It increases the productivity. It decreases the risk of tool breakages. It eliminates the errors, trial and error of iterations on the machine. So that's the first product. Second product, which is the flagship product for us, is the Finesse. So it eliminates chatter vibrations, which is a 100-year-old problem. So if you ask many people if there's a solution which is predictive about chatter vibrations, most of the people will say no, there is no solution. The only solution is operators need to listen and play with the feed rate or spindle settings. So they do this kind of motions all the time on the machine. So that's the current solution. But with our solution, there's a predictive solution now. So because we are addressing the chatter vibrations, we are changing both feed rates and spindle speeds in Finesse product. Additional benefits for this solution is it gives more productivity increase because we are also playing with the spindle speeds. It improves the surface quality because we are solving the chatter vibrations problems, and also reduce workshop noise. So we heard the statistics recently. Every year in the UK, 12,000 people report hearing problems related to their workspace. So we know that chatter vibrations or excessive noise is a problem in the sector. So this is like a tool that can make your workshops less noisy as well. But there is one catch. We have to do a tap test measurement on the machine. This is not completely a software solution. There is a hardware involved, and we provide the hardware, we provide the software, and we provide the training. So the basic tap test is, I don't know, can you raise your hand if you heard about tap testing before? Okay, so majority doesn't know it, but it's basically like what a doctor does when you go for a check. So if they are checking your knee, for example, you might have seen this. They basically tap your knee and then check the reflexes. So we basically do the same thing on the machine tool. So we tap it 5 times in X direction, 5 times in Y direction. And when we do that, we identify the natural frequency, stiffness, and damping properties of the whole machine tool assembly. And basically that measurement is like a fingerprint of the machine. No machine are the same. Their natural frequencies will be different, even if they are the same brand, same manufacturer, same model. As long as the serial number is different, we see different natural frequencies there. For that reason, our recommendations is unique to your machine rather than a general solution. So I will first show how the SenseNC this product works. I mentioned that it autonomously optimizes the feed rates. It considers the cutting loads, stresses on the tool. It also considers the torque and power limits of the spindle. And basically, by setting the optimized feed rates, and that feed rate doesn't have to be just one feed rate. It's basically, it may change along the toolpath, as you see here. So x-axis is the time, y-axis is the feed rate. So it will change throughout the operation. So this is, I think, for one operation. So you see the black one is the nominal original, and the red one is optimized. So red one is quicker. And we tested this technology against the adaptive milling toolpath generation from NX. And as you know, adaptive milling is quite an advanced technology. So it gives better cycle time and gives also more distributed cutting loads on the toolpath. So we wanted to test our solution compared to the state of the art. And this test was done in Glasgow by a CAM programmer who had worked for Rolls-Royce for a long time. And he will tell you what he achieved with this in this next video.
It's particularly interesting that we're using an adaptive clearing strategy. So we use NX to generate an already quite efficient toolpath. What productive machines have done is they've looked at the cutting forces. So we have a 15 millimeter deep engagement, and we have a consistent engagement throughout. But as you enter corners and you exit corners, you have an increase in your amount of engagement based on the angle of that engagement. So that increases your force, or decreases your force as you come out of the cut. So they look at the overall force through the whole toolpath, and then they pick a level, and they increase your speeds to get up to that level, or decrease so that you don't put undue stress on the components. They can also do optimization for non-cutting moves. So they know exactly when you're retracting away from the material, and they can make it go to a G0 on the rapid transfers. So you can get a lot of cost saving or a lot of time saving.
So there was a critical moment when he was explaining. He said they pick a level. So basically we pick a level for each tool, tooling assembly. So we say this tool, for example, could be okay until this stress levels, until this force, until this bending moment, until this assembly can take torque until this value. So we take all these complex decisions with the software rather than the engineer or the CAM programmer. So there are solutions in the market like Vericut Force. Maybe you may have heard about this technology. Third wave production module. They all rely on expertise of the CAM programmer to set those levels. So somebody has to say, okay, this tool will go up to 1,200 Newton. That tool will go up to 3,000 Newton. So that requires quite an expert knowledge. But what we did is the expertise is hidden behind this technology. So the constraints are all set by the user, constraints are all set by the product rather than the user. And we did a demonstration in the Siemens Realize Live Detroit event 3 weeks ago. And we work on the gear. Okay, sorry about that. So thanks to Claudia, I'm able to make this presentation. But yeah, there may be some messages like that. So we have given extra 25% increase in productivity on that gearbox casing component. and the part was there in Detroit. And I will show how the technology works. So our engineer will basically show to you how he optimizes the operations in that file. It will take about half a minute, 1.5 minutes, but yeah, I think it's worth showing you how easy it is to use it.
I'm going to show you how to use SenseNC feeds. The add-on appears when installed. First, we need to enter our credentials to log in. Then we will have two options. For this demo, we will start with submitting a new optimization. First, we need to choose our optimization type and our machine tool model, as well as its spindle. Next, we will choose the toolpaths that we would like to optimize. Here I selected a few. We also need to set their tool data. As I've done this before, I can easily import them from our database. And lastly, we need to choose our material. Now the toolpaths are sent for optimization. We can go back and have a look at a couple of finished toolpaths. Here I'm going to select one. I can see the optimized toolpaths. I can set a productivity level, which allows me to define how strong the optimization is going to be. I can import them. The toolpaths are imported successfully. I can see that I did an X. And also I can download the report. Downloaded reports are individual to each toolpath and gives me original and optimized cycle times, save time, and the productivity change. I can also see how the feed rates have been changed. Here the original feed rate is shown in blue, whereas the optimized is in orange. I can see the chip thickness and cutting forces.
So this is basically you submit an optimization request, and then on the cloud the optimization is running. We also have on-premise server solutions. So the advantage is that your workstation is not busy running a complex computation. So computation is happening either in the company servers or on the cloud. And when you are basically waiting for the optimization to come, it could be like 5 minutes, 3 minutes, depending on the length of the toolpath. You are able to do other things with your workstation. You get an email saying that your optimization is complete. These are the KPIs. And then, as my colleague showed, you basically import the operations into NX, and everything that we do stays in NX. So we don't break the digital thread. So you continue with your process. You go to the post-processing, and then you basically create a part on the machine like you do all the time, with the additional productivity and quality improvements. And this product is available in Siemens Marketplace. Armin had shown a link to it yesterday. We are very happy to collaborate with Siemens. So basically anyone now can go and check the QR code and then see the product in Siemens Marketplace. Now the next part of the presentation is about the Finesse product. This product is solving chatter vibration problems. So it has a unique selling point. And I will show you how it works, but I will show you first the result. So first video is the original toolpath. This is the video coming from the first case study that I will present in a moment. So this is one of the whole milling operations. There were 12 toolpaths, and we are just seeing one of them here. So this is how it sounds in the original toolpath. Maybe it's okay now. Can stop it. Yeah, so this is not a sound that the machinist would like to hear in the machine. So this is the sound of the bad vibrations, or we call it chatter vibrations. And in the optimized process, it sounds like this. This sound is not chatter, this is normal. And if you pay attention to the spindle speeds and feed rates, we increase them considerably. In fact, the productivity on this toolpath is 3 times more, 3 times the original. So there is 3 times improvement in productivity there. But of course, not all the toolpaths generated this kind of results. Overall, we achieved about 21% improvement in productivity. So that means that some of the operations were slower, but some of the operations were as fast as 3 times. But I will show you the other benefits of this technology in a moment. So how does the software do it? I will just show you some results that are available in the report. Just one thing that I want to highlight, the user, the CAM programmer, doesn't need to look to this report and doesn't have to make any decisions looking to this report. These reports are only there for traceability, for giving understanding to the user why the software changed things. That's it. So the change of spindle speeds and feed rates are automatic. And in the original toolpath, so we looked, software basically creates a stability heat map in the report, and then basically in the whole area you see some colored areas here. So that shows that we are expecting medium severity chatter vibrations before we cut any material. So this is before cutting any material. We have this kind of knowledge available in the report. And then what software does is software, as you have seen, change the spindle speed and feed rate. And software thinks that now there is no chatter vibrations risk because there is no colored area. So we don't like to see colors in this kind of charts. And then software looks to another diagram. Again, this is in the report. It's called stability map. In the stability map, x-axis is the time, y-axis is the spindle speed. If your spindle speed goes through colored areas, again, it's bad. Ideally, it should go through white areas. Depending on how much productivity you wanted, for example, I think this machine was 12,000 RPM. So you cannot go more than 12,000 RPM. I think the level was 7 here. So if you pick the level 7, which is the highest productivity level, the software will take it to 10,000 RPM. But default setting is level 5. So if you don't change anything with the productivity slider, level 5 will be probably around 8,000 RPM. So software makes that decisions, and basically you have a more optimized toolpath as a result. And I will show you the case study here, which is where the video is part of. So there was poor surface quality problems on this part. The process that I showed you was roughing. So because the part was finished, so all these terrible chatter marks were hidden in the finishing process. But again, after the finishing, the surface quality was still not great. And there was excessive noise coming from the machine. So the operators don't like the excessive noise. We are working with a large company. The reason they are working with us is because the team that is next to the machining team are not happy with the noise that the machining team was creating in the factory. So we went there to reduce the noise complaint from the neighbors to the machining team. And what we did is we applied the SenseNC SenseNC finesse product to address the quality and noise issues. And result was 50% improvement in surface quality in the finished component, finished surfaces. So you see the surface roughness measurement. We did like 10 different measurements. I cannot present all of it, but this was the average of the measurements, around 0.7 micron array. And the optimized one, again, this was the average, about 0.34. So we decreased the average surface roughness, but we also decreased the variation. So this array value was all over the place between 50 micron up to 90 micron. Whereas in the optimized one, the variation was only a few microns. So it's more stable throughout the surface, and it's lower as well. And as an additional benefit, of course, this process is faster. So instead of an hour, it takes less than 50 minutes, if I remember correctly. Yeah, around 50 minutes. And I will share the video where the engineer from AMIC is explaining the benefit in his own words.
Productive machines technology was quite impressive, to be honest. They not only remove vibration, but they improve the surface finish of the component, whilst at the same time getting a cycle time reduction of around 20%. So they give us appropriate cutting data, which we ran and then optimized it. So the benefit of not having chatter is obviously improved spindle life, tool life, which is cycle time, better component quality, we actually found that the surface finish reduced by 50%, a smoother surface, cycle time 20%, and also the environment is less noisy, so it's a nicer environment to work in without noise from chatter and vibration.
Okay, so this was the first case study that I wanted to present to you. The second one is the reshoring case study, which is we are really proud of. So the background to this story is there was a large tier 1 aerospace company, and they were subcontracting parts to overseas, and they were having some delivery and quality issues. Because of those problems, they gave a small job to a company called AML Sheffield, based in Sheffield. We are also based in Sheffield, and they were given a 6-month contract to produce 3,000 parts. So if you are from the aerospace, usually you will know that usually the contracts are longer term, like 1 year, 5 years, 10 years. So basically they were given a chance because there was a problem, but they were told specifically by the tier 1 company, if they don't reduce the cost, they won't have the long-term contract. So they had to reduce the cost. For that reason, they invited us to this challenge, and we gladly accepted it. Again, we applied the SenseNC finesse product, and we basically wanted to minimize the cycle time by using the maximum potential of the machine. And I will let Alex from AML Sheffield to share with you the results.
So AML does subtractive machining of metallic components, mainly for the aerospace and energy sectors, with a little bit of defence. We mostly focus on land-based gas turbines and aircraft propulsion systems, and we're based in the Advanced Manufacturing Park in Rotherham. So there was a tier 1 aerospace supplier. They were struggling with delivery from a previous incumbent on a business jet aircraft engine component. So they asked AML for help. They awarded us a 6-month contract to produce 3,000 components, with a view that we might be able to win a 12-month contract in the back of it if we could reduce the cycle time and therefore reduce the costs. We fully optimised the process using traditional engineering techniques, and we reduced the cycle time down to an hour, but we were stuck at that point, so we needed extra help. We approached Productive Machines, who are experts in machining dynamics and simulation, to use their SenseNC plugin to optimise our toolpaths.
SenseNC Finesse is Productive Machines' autonomous solution on toolpath optimization. It optimizes both spindle speeds and feed rates. It works by taking cutting parameters, material data, and machine parameters into account, and analyzes the toolpath at every cutter location. To optimize spindle speeds, first we do a tap test and take the results of tap test into account along with cutting tool data. This gives us chatter-free toolpaths. When it comes to feed rate optimization, we do that based on cutting forces, and this allows us to have reduced cycle time, better surface finish, and longer tool life.
Production Machines were able to reduce our cycle time by over 20%, and we were able to pass those savings on to our customer. So if we were to optimise our machine toolpaths ourselves, it could take a number of years, but through the use of Production Machines software, this can take minutes. For the modern machining organisation, time is key. So optimising machining strategy is absolutely vital. And Production Machine solution is not only easy to use, but integrates seamlessly with SenseNC.
And another thing that I want to say, so they are using this software, and now they won another contract for a second part. So the second case study is showing that this is not just chance. So this happened again, and now they have a 5-year contract for another part that we supported with the software. Just to wrap up, so we have the autonomous milling optimization software SenseNC available now for the manufacturers. And as I mentioned, SenseNC Fits product is available to purchase. Basically, there's a free trial version, so you can basically download it and run 5 optimization with it free of charge. You can see the impact yourself in your own machine. Then if you want to use it further, then we can have a discussion, but it's like a self-service. We can give you a username and password after you fill some details like username, and basically you need to give you a username and password. After that, you are okay to use it in your own time. Of course, we are happy to support, but there are companies that are starting using this technology without our involvement. And the benefits are, we saw that the manufacturers were able to reduce the cost with this technology by optimizing the feed rates and spindle speed. they are able to increase the production capacity by making sure that they can use the maximum potential of the machine. Our biggest work, when I say our biggest impact, was Rolls-Royce project. So at that time, the technology wasn't in productive machines, it was in the AMRC environment, but some of you may know, like, there was a very popular project called HPDM in the UK, high performance disk machining. So by making the optimization of the processes using earlier versions of this technology, Rolls-Royce had reduced the cycle time of disks by 50%. And when you decrease the cycle time by 50%, you basically can buy, how to say, I think they bought 50 machines. So instead of buying 100 machines, they bought 50 machines and creates the factory with 50 machines. So depending on where you are in the journey, especially if you're in the early days of creating a factory, the impact can be huge. But even if you have a brownfield where you're already producing, as I said, next day you can start achieving 20%, 15%, depending on the operation. You can start benefiting from the technology. And the last one that I want to mention is it also improves the part quality. So it basically solves the service quality issues. It solves issues about the forces, so dimensional tolerances are likely to be better compared to unoptimized processes as well. And they are all solved at the CAM stage, not after the machine has done something. So we solve it before you actually machine the part, start machining the part. And that concludes my presentation. Thank you for your attention and happy to take your questions.